everyone, so I wanted to show all the parts that build my Rover project. So I will just quickly go over all the separate parts that are here. So first of all, I have this battery bank, so I can easily take it out, as of course those are LiPo batteries, so we need to be safe. And I can just take it out. It's, as you can see, 3 LiPo batteries, 4 cells, so 14.8 volts each and 5000 milliampere hours. So I can just slide it out and take it out. They are connected with those connectors, those to go to motors, and that one powers all the electronics. And this sensor can be turned upside down for the space for the batteries. Then going from the front, those are 3 proximity sensors that of course can stop it if it hits something. They are on the level where the tracks start going backwards, so in case if something is lower, then it will go over it, and if something is high enough that it will be hard to go over, then it should stop them. Then here are the 4 LED lamps, each 3 watt LEDs. There are 2 pairs. One pair is wide angle, one part is narrow angle. Then here are the 2 ESP32 cams that will be used for the stereo vision. Next, this is not attached yet because I wasn't using this today. This is LTE router that provides internet connection. This is tapelink with OpenWRT and WireGuard on board, WireGuard VPN, that allows me to connect to Mido and to all other onboard ESPs over the VPN connection. Next, I have Mido F7 board. That is the heart of the whole project. Here I have small screen that is showing me some basic information. This is a 16 by 2 screen. It's showing me like something happened, can show error message, etc. It shows what is it doing right now. Here this is bigger 20 by 4 screen that is showing me the batteries, voltages. I have this also in the application, of course, but just in case if it's not connected, if it's not providing information in the application, I can quickly check the batteries on the screen. Here, this is the switch that is switching up all the electronics. And here I have one INA 280 sensor that is measuring the voltage and amperage and the current on the main battery. There are 2 more that are inside this blue cover there. It's hard to see, maybe from this side. Oh, you can see there are two more sensors here. They are in this cover because there is a fan, so they can be easily cooled. Oh, there's a fan so those 2 can be easily cooled down, because they are powering the power to the motors goes through there, so it can be quite high power. So I prefer to have them with separate cooling. Here are also 3 breakers. Each of those is 20 amps breaker, so they could be enough to protect the batteries from some short circuit or something. Those 2 up are for the motors. This one down there is for this one is for the electronics. Here, of course, I have the motors. This is one. Second one. This is the back side of the second one. They are connected with sprocket and chain to the main axles, and those axles are powering the tracks through these 2 sprockets. And the tracks, as you can see, are built around 2 strong chains, 2 iron chains, and to each link, each link there is connected aluminium board. For now, this is connected that way with those screws. I'm planning to build new version that will use chain that has some kind of attachments on the sides, so it will be easier to screw everything together, because this chain is not perfect, but it's working. As you will see later, this is the whole suspension, how it's working. You will see later on the video how it's working with the rough terrain. But as you can see, this is just a lever and a spring. So if it goes up, the spring takes it down. That's simple. Simple but working. So we have five those wheels, and the tensioning wheel. Tensioning wheel is connected with something similar. I can show on this side. This is like reverse of the reverse of that one down there. So this spring is tensioning. Oh, it's doing two things. There are two springs because this needs more force, and it's doing. Oh, it's really hard. It's tensioning the tracks, and also if the track will hit something, this will go back, and of course this spring will take the force of the hit. So it also then. For the smaller parts, here are the PCA boards that are providing the PWM signal. That one is where's my finger? That one is set up at 1600 hertz. That one is at 50 hertz because this one is controlling the servos. For example, those two servos that are controlling the gimbal of with the camera, and this one is controlling this 1600 is controlling the motors and also the LEDs for now. So, and I have a lot of spare connectors in case if I will need more signals in the future. This is just RTC clock, basic clock that keeps track of the time. So when the board is booting up, it's just reading the time from the RTC, so it always has correct time. Of course, from the application I can also set this if the time is incorrect, I can set it from the app control application, and then it's saved also to this RTC. Here, for example, is the BNO 055 inertial measurement unit. So it is providing the position in the this is providing the position for the whole rover, so it knows if it's tilted, if it's pitched up or down, and take action according to that. For example, camera gimbal is using this, or when it's turning, then it's reading the current yaw, and then it's turning up until it will, with PID, up until it will turn to the correct new correct position. This is just I2C bus. This is literally I2C bus, so it's all the I2C I2C devices are connected to this bus, and then it's connected to the I2C connectors on the middle board. Behind there is it's hard to see, but there's MCP 23008 expander. This one is controlling the proximity sensors, the three in front, and there's also one in the back in case if it's going back. So they are connected to this, so I don't need to use too much connectors on the middle board. And also this is just this is the place where all the sensors, proximity sensors are connected and have power from one bus, so I don't need to use all the pins. Up here, down there are back converters. If we can see them, maybe go to this side. It's easier to see from this side. There are 3 back converters. One provides 3.3 volts, one provides 5 volts, and one provides 6 volts for the servos. And let's, for example, let's have a separate back converter. Sorry. So each of them is connected to bus here. So this one is 3.3 volts. This one, full one, is 5 volts, and there's a third one with 6 volts. And this is ground. Then here I have another MCP. This one is controlling other stuff, like for example fans, so it can turn on and off the fans. Also it will be controlling also the cameras later. It's not set up yet because I have a lot of work on these cameras and stereo setup still, but yeah, this is just the transistors, so MCP can switch on and off the power. this is NPN transistors, so the MCP is just switching those transistors here, and this is also one NOT gate, so for the beeper. So I'm using this the inverted signal from the MCP, because when it was turning on then it was constantly beeping and, up until the port was connected to MCP. So I'm using the reversed signal, that way it's silent. Here is of course the beeper. It has tape on it because it's too loud when I'm working inside. Next, here are the double H bridges that are controlling the motors, and switches for them that are turning the power from the batteries on and off. And each of those has a fan also to keep them cool. Each motor has also Hall effect sensor, so I can count the rotations of the shaft, of the drive shafts. That way I know how much it went forward or backwards. There's also a servo that's changing gears. As you can see, this metal there, this is the lever that was inbuilt in the motor, and then this lever from the servo, it's moving it forward and backward to change the gear. It's doing it for the both motors. It's hard to see, but you can maybe see that this is one, this is second. And here is another buck converter. This one is providing 5 volts. This is just to be safe. This is powering USB devices, because this is exactly 5 volts, and this cable is just USB connector, so I can connect, for example, the routers, or if I will need something else later, it's easier that way. And those are the two buck converters that are powering the LEDs, because the LEDs need exact current. So both pairs both pairs have separate buck converter just to be safe. And this is PNP transistors that are controlling the LEDs, and those small are NPN transistors that are controlling those PNP transistors, and they are controlled from the PWM signal from the other side. So and of course here's the camera gimbal. It might feel a bit oversized, but at first there was an action camera connected there, so it needed to be stronger. Later I decided to use this camera that will be connected straight to the control applications, this ESP cam, so it's lighter, but I decided just in case I leave this bigger servos, so in case if I will want to connect there something else. Oh, and I forgot about this. This is HC12 board that is providing the wireless connection. It takes the serial signal and it's converting into 430 MHz radio, and this is the antenna, and this is the main way of communicating with the rover. And after I connect with this, I can switch to UDP communication for now. Maybe I will program also TCP, but to be more reliable. But I guess UDP should be enough, at least for now. And yes, this is the way it's working. It's connected to the serial port on the Mido board. And I guess that's it. So thanks for watching, and next I will show some footage of it going around. I just tested how it's working on the rough terrain. Haven't tested all the, let's say, more intelligent things yet, but I hope it will be interesting. Thanks for watching.